Welcome to Day 2 of our NISM Series XA Level 1 preparation. Today, we focus on the central pillar of the exam syllabus, the time value of money. Navigating the calculation sections of this exam requires more than an understanding of theory. It requires a precise grasp of spreadsheet mechanics. We will master 4 specific calculation frameworks used throughout the workbook: simple versus compound interest, future value, present value, and annuities. By the end of this session, you will be able to translate complex word problems into the specific Excel inputs needed to reach a consistent, accurate result. At its core, the time value of money is based on a single principle. A sum available today is worth more than the same amount in the future because it can be invested to earn returns immediately. To see this in practice, consider a baseline workbook scenario. Suppose an investor places 5 lakh rupees into a 5-year bank deposit at an 8% annual interest rate. Under simple interest, growth is linear. Without reinvestment, 5-year returns are exactly 2 lakh rupees. Choosing the cumulative option reinvests interest, bringing total returns to 2,34,664 rupees, a 34,664 rupee difference created by compounding. Understanding this acceleration is a prerequisite for the multi-year wealth projections you will be required to perform on the exam. For these projections, the primary tool is the Excel Future Value, or FV, function. We start with the rate input, which is the 8% annual return from our example. Next is NPER, representing the number of periods, in this case, the 5-year time horizon. We leave the PMT field at 0, as this calculation involves a single initial investment rather than a recurring payment. Excel uses a specific cash flow convention. Outflows are entered as negative numbers. Here, we type -5,000. This yields a positive future value of 7,346 rupees and 64 paise, reflecting capital growth. Maintaining this sign convention is a key step in ensuring the final output matches the logical direction of the cash flow. The present value analysis reverses this logic. It determines the current worth of a specific amount, or a stream of amounts, that will be received in the future. Let us consider a new case study. We need to evaluate an annual payment stream of 6,500 rupees over the next 8 years, discounted at a rate of 7. When calculating the value of an annuity, the outcome depends on whether the payment occurs at the beginning or end of each period. Excel's type toggle controls timing. Type 0 means payment at the end. Type 1 means payment at the start. For a 4-year 5,000 rupee payout, Type 0 yields 15,849 rupees. Type 1 increases this to 17,434 rupees, as capital earns returns longer. Selecting the incorrect type will result in a discrepancy that does not match the options provided in the examination questions. You now have the mechanical tools to project future wealth, discount cash flows back to the present, and value complex annuities. Re-verify your inputs before finalizing any answer. Ensure outflows use negative signs, and check the payment timing for the type toggle. For immediate practice, try adjusting a formula for monthly compounding by dividing the annual rate by 12 and multiplying the total periods by 12. Applying these software mechanics reduces the calculation of multi-year scenarios to a repeatable process. Subscribe to the channel and join us for Day 3 as we continue the series.